Hi, my name is Bruce Case. I'm an applications engineer for DAIRYLAND Electrical Industries. In the course of answering phone calls and technical calls here at DAIRYLAND, it becomes apparent that it would be a good idea for us to do just a brief review of what a decoupler is and how it is used. We are going to delve into the functionality of a decoupler in just a moment, but let's briefly describe what a decoupler does. In the oil and pipeline business, metallic structures, including such things as pipelines and tanks, are made more corrosion resistant by the application of a negative voltage. An understanding of this galvanic protection process is really outside the scope of this talk, but there is an entire industry devoted to application of this principle. The challenge is that these negatively charged structures also require a means of safety grounding, but the two goals stand in opposition to each other. How to ground the structure without interfering with the negative charge. Enter the decoupler, a solid-state device that allows safety grounding of a structure, such as a pipeline, without interfering with the protective charge that is placed on it. Now that we have a very general idea of what a decoupler is, let's discuss two different aspects of the decouplers, where they may be used, and what are the typical applications. The first thing we need to explore in terms of the question, where are decouplers used, is an understanding of hazardous ratings. All electrical products rated for use in a hazardous environment are assigned a class and a division rating. The nature of the petroleum and gas industry dictates that at DAIRYLAND we are primarily concerned with flammable gases and vapors. Because of this, we have obtained Class 1 ratings on all our products. You can see from the chart that there are other possible location types or classes, but these are environments not generally applicable to the gas and oil industry. We need to further subdivide the class rating into two different distinct areas called divisions. A division rating of 1 implies we have a type of environment where an explosive environment can exist under normal operating conditions. A division rating of 2 implies that an explosive environment is an abnormal operating condition. Let's explore these division types more closely. Let's talk about a Class 1, Division 1 hazardous rating first. This is a situation where explosive gas or a vapor can normally occur. This is a common situation in several different industrial areas. The first is in the normal processing of fuels, such as inside a refinery area, where gases and fuels are often present and part of daily operations. Another area that requires this rating is spray painting areas, where explosive vapors are a normal part of operations. Often, DAIRYLAND will install equipment at airports, where fuel is handled both inside hangars and on flight lines. Finally, at gas processing plants, the venting of explosive gases is a normal part of operations. Another situation I should mention is where electrical equipment is placed in a pit, where the accumulation of gases and vapors can readily occur. You should be aware that different companies interpret what is a gas venting area differently. Some would say within 8 feet of a vent. Others would have a different corporate policy, possibly more or less restrictive. A slightly different application is a Class 1, Division 2 hazardous rating. This is a situation where explosive gases and vapors don't normally occur and in fact, it's an abnormal condition. Usually this division rating is associated with a breakdown in a plant operation, such as a rupture of a gas line or possibly the breakage of a storage vessel. For Dairyland, the installation of our decouplers on an insulated flange is very common. Here we are concerned with the breakdown of the flange insulator and the venting of the pipe contents. But again, this is an abnormal situation. In this matrix chart, I am showing the family of decouplers that Dairyland builds. If you look along the top row, you can see the Class 1 Division 2 rated products offered by Dairyland. These three products are the PCR, or polarization cell replacement, the SSD, or solid state decoupler, and the OVP2, or the over voltage protector type 2. Because of their common hazardous rating, these products can be used in any situation where it is an abnormal situation for explosive gases to accumulate. If you look along the bottom row, our product offerings include the PCRH, or polarization cell replacement HAZARDOUS, and the OVP. Both products are rated for situations where explosive gases and vapors can commonly occur. A further element to consider in this chart are the columns. We will talk more about this later, but if you look at the left-hand column, these products are rated for electrical environments where AC is present across the terminals of the decoupler. The right-hand column indicates products rated for environments where there is no AC across the terminals. More on this later, but this matrix fully defines the operating environments for all Dairyland decouplers. Let's turn to the question of why a decoupler is used by looking at an application involving a simple pipeline. Although this scenario is not very common these days, it is valid for illustrative purposes. Our goal is to achieve some level of corrosion protection on the pipe. And to do that, we're going to bond the pipe to a series of sacrificial anodes. In this case, we're trying to actually polarize the pipe to a negative level, and we do that by hooking it up to a zinc anode. This lecture is not going to cover the theory of galvanic protection, but basically the zinc anode will move current into the pipeline because of a difference in galvanic potential, with the net result being a negative polarity created on the pipeline itself. This kind of scheme offers a very limited level of protection. The anode system itself has a fixed amount of current that it can move into the pipeline, and so its ability to actually drive the pipeline to the correct negative potential is really affected by the nature of the soil and the amount of surface area of the anode that's available to move current. The more popular scheme, and one that offers us the ability to directly control the amount of negative polarity on the pipeline, is to literally hook it up to a DC supply or a rectifier. In this diagram, you can see the pipe is bonded directly to a rectifier, and the rectifier is bonded to a sacrificial anode bed. In this case, the positive terminal of the rectifier is connected to the anode bed, and the negative terminal is going to be connected directly to the pipe. The goal is to polarize the pipe with a negative potential. This is a much more robust type of scheme because the rectifier can now provide substantial amounts of current to help polarize that pipe. Our simple anode system that we had previously discussed would be very limited in its ability to do that. Although we have now provided a technique to give an appropriate level of negative voltage on the pipeline, we also need a means to provide safety grounding of that pipeline in the case of an overvoltage situation. We cannot directly bond the pipeline to a ground, as we will drain off the CP voltage we have worked so hard to provide. In this picture, I have introduced a decoupler, which functions as a smart switch. We will talk about conditions that energize that switch shortly, but for now, just realize that the decoupler is continuously monitoring the pipeline for any excessive voltage and will energize when certain criteria are met. Let's talk just a bit about the theory of DC voltage blocking. This is a diagram that shows the voltage across the decoupler terminals. It is simply a graph with a negative voltage to the left and a positive voltage to the right. The goal of pipeline operators is to polarize pipes negatively enough to meet the industry criteria, which we won't be going over here. However, it's typically about where I have an arrow labeled operating point. Within this operating region, which is illustrated here by a central gray area, we don't want our decoupler to actually be passing any DC current off our pipeline. We want the DC to be blocked. The decouplers that DAIRYLAND manufactures actually have a zone or a band where they block DC power flow. Typically that's from -3 volts to a +1 volt, as illustrated here. We also offer this in other configurations. Another common one would be -2 volts to +2 volts. We'll talk more about selecting blocking levels in another video. You will note that the DC blocking range of voltages is biased towards the negative side to accommodate the negative charge on a pipeline. Besides reacting to fault conditions created by excessive DC voltage levels, the decoupler also has to react to various AC situations. We're going to be talking about some of these conditions in just a moment. Just remember that the decoupler behaves like a smart switch, constantly monitoring the pipeline and only doing what is required in the right situation. Let's talk about AC faults that can happen. If we're operating a pipeline and we're located underneath overhead power lines, or we're connected in any way to a potential source of AC power, we need to be able to deal with something bad that could happen. In this situation here, I've illustrated a power line falling and coming in contact with a pipeline. While this is probably a remote catastrophic event, it is electrically similar to a pipeline-mounted pump motor or a motor-operated valve shorting out. If that were to happen, it is very important that we move the power that is temporarily on that pipeline to a safe grounding condition. Our decoupler is in the grounding path, so it has to react to this type of AC fault. You remember from our previous slides that we're blocking DC levels within a -3 to +1 volt level, but we always need to pass AC to ground for safety reasons. If an operator or a maintenance worker is touching that pipe, it's important that that pipe remain safely grounded during an AC fault condition. In the event of a fault, the decoupler will become a fully conducting device but revert back to its DC blocking mode after the fault passes. To further understand AC fault conditions, we need to take a brief look at AC circuit breakers, since not only power lines but pipeline devices actuated by AC voltages are all protected using them. To make this understandable, I'm going to talk about a typical home 15 amp circuit breaker. Even though we may call this a 15 amp breaker, it's very important to understand that the 15 amp rating only has meaning for long periods of time. If we look at this chart, we actually have time on the vertical axis and we have current on the bottom axis. As we move down the vertical axis to small amounts of time, it turns out that the circuit breaker will actually pass significantly more than 15 amps. So let's say we had a direct short in our house, a light bulb or a motor burnout, or something happened to cause a direct short on the power line. You can see from this chart that for a very brief amount of time, such as say 0.05 seconds, the circuit breaker will actually pass 105 amps before it were to open. If we go to a slightly longer time, say a half second, that circuit breaker would trip at 90 amps. Finally, if we really draw that time out to 16 minutes, the circuit breaker would trip at 15 amps, its actual rated current. So you can see a circuit breaker will pass significantly higher current for short periods of time, but trip at the 15 amp rating only when there is a long duration shorting event. This is an important concept to understand because even though this is a small circuit breaker, the same principles apply to the circuit breakers that are used on large utility overhead power lines. Let's talk a minute about the way current passes through one of our decouplers. On this graph, I have time represented on the bottom axis, but I've actually labeled it AC cycles. In the utility industry, it is common to not use seconds, but to use a number of cycles. In America, we have 60 hertz power, or 60 cycles per second, so 1 second equals 60 cycles. In foreign countries, it's not uncommon to have 50 cycle power, or 50 hertz power, so 50 cycles occur in 1 second. So if you look at the bottom axis here, I go up to 30 cycles, and that really represents 1/2 second in America. On the vertical axis, I have amps. That's the amperage that our device is rated to carry for a certain number of cycles. You can see that for very small amounts of time, say 1 cycle, our device would pass a large amount of current. But as time goes by and going up to 30 cycles, you can see our device cannot withstand the same high level of current. This is just a typical performance curve for any electronic device due to the heating that occurs from the large amount of current that's flowing through it. Here I have the same chart again, but I'm illustrating it specifically for one of our devices. This is the PCR, or polarization cell replacement unit, with a 3.7 killiamp rating. What that rating really means is that this particular PCR is rated to pass 3,700 amps for 30 cycles. For time less than 30 cycles, it can pass significantly larger amounts of current. It's important to understand this concept of current decreasing with time when we talk about the rating of our device compared to the rating of the circuit breaker that may be protecting an AC power line. So on this chart, I superimposed the circuit breaker performance controlling, say, a motor-operated valve underneath the performance of our decoupler. You can see that our decoupler behaves like a circuit breaker. It is rated to pass large amounts of current for short time, and then as time increases, the rated current it can pass decreases. When you as a customer call in and say, "What level of fault current do I need to purchase in a decoupler?" the answer lies in the amount of current your faulting device can deliver. So generally, we'll talk about the ratings of the circuit breaker connected to your device. If it's an overhead power line, the answer becomes a little more complicated, as not all the current will choose to flow through our decoupler, as there are alternative paths to ground. In that case, we may refer you to a consulting firm that specializes in grounding system design. In this diagram, you can see the decoupler performance shown in green has a better overall performance than the circuit breaker shown in red. So we can safely handle more current than the circuit breaker would be allowed to pass through it. And that's just what we want to see. Let's talk about one of the most common faults that a decoupler must protect against, and that's lightning. In the event of a direct lightning hit to a structure that is protected by a decoupler, we must safely pass that lightning current through the decoupler to the grounding system. This is done to not only protect the structure, but also help protect any workers that may be in contact with that structure. Additional measures can be taken to help protect workers, such as gradient control mats, but that topic will be left to another video. Lightning is particularly a problem for southern states and in Florida, not as common an event for California, but nonetheless, everyone must deal with the potential for a lightning event. We don't necessarily know the polarity of a lightning hit, so the decoupler must respond to both positive and negatively charged events. In the case of our standard decoupler, any potential less than -3 volts or greater than +1 volt will trigger the decoupler into conduction. A lightning event has potential well outside of those numbers. This is a drawing of what happens in an actual lightning hit. Lightning is a very short time event with a large amount of energy. And generally in America, we talk about an 8x20 lightning performance curve. And this is what that looks like. On the bottom axis, we have time in microseconds, here specifically labeled at 8 microseconds and again at 20 microseconds. On the vertical axis, I'm showing current that flows from a lightning bolt. 8 microseconds is generally regarded as the point where we are built up to almost the maximum current flow from the lightning bolt. And 20 microseconds represents the time when that level has dropped to about 1/2. You can see that this is a very short-term event, but amperage can be extremely high. In this case, reaching 100,000 amps at the peak, not an uncommon event. All DAIRYLAND decouplers need to react to lightning events, and most decouplers are rated to 100,000 amps of current. Only the very smallest SSD product is rated at a slightly reduced 75,000 amp level. Another big problem that's actually of growing concern for pipeline operators is induced AC that gets coupled into a pipeline due to the fact that it's located close to a major AC power source. Generally speaking, it's because the pipeline is sharing corridors with overhead power lines. The amount of AC that magnetically couples onto the pipeline is a direct function of how close you are to the overhead power line, the amount of current that happens to be flowing through that pipeline at any given time. You may find that the level changes dramatically over the course of the day as usage goes up and down. The orientation of the pipeline to the overhead power line may also affect the amount of AC that gets induced onto the pipeline. As we look at previously, and we'll review again in just a minute, some of the DAIRYLAND decouplers are not rated to deal with induced AC conditions because they will actually trigger into conduction and will stay in conduction continuously a mode they are not designed to operate in. Most of DAIRYLAND decouplers are rated to continuously pass 45 amps of AC current. Some of our products, such as the PCR, can optionally be built with an extended 80 amp continuous rating. We do have other families of products that can go even higher, but we are not going to cover those in this presentation. To briefly review, decouplers in the left-hand column are designed to operate where there is AC continuously present. Decouplers in the right-hand column are not designed to be operated where AC is present. When picking a decoupler, it is important to pick the correct product. If your installation is a remote location and you're not located close to a power line, it's not unusual to have no AC present, but in most urban settings or where a pipeline parallels overhead power lines, generally there will be some AC present. The presence of AC can easily be verified with a simple handheld meter by measuring AC potential from pipe to soil. That concludes this brief discussion of decouplers. If you have questions, please always feel free to give us a call here at DAIRYLAND, and we'll respond quickly to any questions you may have.